Okay, so let's do the practice now. Read each scenario, identify the independent and dependent quantities, and be sure to include the appropriate units of measure. Then analyze each graph and determine which of the provided scenarios is models. So it's gonna be the same thing we did in our notes for activity 1.1, which started back on page M1-9. Those are the set examples we're gonna use here. Okay, so for the endangered species, the Elkwood Aquatic Society is working with various reptile species to increase their populations. The initial population of 450 endangered turtles tripled each year for the past 5 years. So on letter A, first thing we're going to do is identify the independent and dependent quantities. Okay, so the independent quantity, as I'm reading through this, is all about time. So there's time in there. And we are talking about time, it says over years. The dependent quantity then is going to be the number of turtles, population. Number of turtles. Okay. So from there, it says, okay, the initial population of 450 endangered turtles tripled each year for 5 years. Now, when you start tripling each year, just like we did the doubling problem back in our notes, which was the interest one, it should look like something that is what we call like an exponential growth. It should kind of curve up very quickly. So this is going to be associated with graph letter E. Okay. So I go look at graph E. We're starting down there at 450, and then it's tripling every year. So our x-axis will be the years in time, and then our y-axis is the number of turtles. Now that's all they're asking us to do. They're asking us to determine a scale or anything like that. But I would think myself, if I was going years for time, I would go by ones, okay? And then from there, trying to figure out the scale, I probably, since we start off at 450, I probably would start off at 400 and increase like that. Now for the rest of our homework problems, I'm just going to label out the axes, and that will be it. Letter B, video games. Gillian is playing video games at an arcade. Gillian starts with $40 and is playing games that cost 50 cents each. Game. No time, okay? We have no time here. So something a little bit different for the independent and dependent. For the independent, since there is no time. What's happening? You're playing games. A number of games, and what's then going on? The number of games you play is going to decrease your money, which is in terms of dollars. So as you keep playing games at 50 cents per game, because that's a constant rate, what I should be seeing is like a straight line, either going up or going down. But if you start with $40 and you start playing games, what's happening? Your money should be going down. And the graph that matches up with that of A, B, C, D, and an F that remains is letter C. Okay, so this is going to be with graph C, where this is the number of games, and this is the money you have remaining, which is in terms of dollars. Letter C, sales commission. Julian works as a salesman. He receives a monthly salary of $3,000 as well as a 10% commission on the amount of sales. So some jobs are like this where you automatically get $3,000, and then after that you'll get an additional set amount of money based off how many sales you make. Now there's no time here, okay? So we need to think a little bit differently for our independent. So you get a salary, and in this instance, your salary is going to be based off how many sales you make. So this is going to be your monthly sales. And then from there, the monthly earnings. Earning is what you get to bring home. So if you make X amount of sales, you get then X amount of earnings, $3,000 plus so much more. Now, both of these is about dollars. So what I mean by that is, if you're selling something that is worth $1,000, you're going to get 10% of that $1,000. So 10% of 1,000 is 100. So you're going to get $3,000 plus an additional 100. And then if you sell something that's worth $2,000, you get an additional then 200 on top of that salary. So that's why they're both like that. Okay, so we are looking for something that should be increasing. Though in this case, it should be increasing steadily at 10% of that for your commission. And it starts off kind of high because your base salary is $3,000. It's increasing. A is not increasing. Now D is, and also B is. F is not increasing. But you're not going to flatline. Okay, you're going to keep increasing as long as you keep making sales. So in this instance, it's going to be letter B. So this is going to be graph B. This is going to be your monthly, let me try to spell monthly sales, which is in terms of dollars. And this will be your monthly income then. That's how some of these jobs in the real world work. Letter D, cooling tea. A freshly made cup of tea is served at a temperature of about 180 degrees Fahrenheit. The tea cools gradually at first and then slows down gradually as it approaches room temperature. Okay, so as we got here on letter D, we have time happening, okay? So as the time progresses, this thing is going to cool down. So my independent's going to be time, and your dependent is going to be then the temperature, which is in terms of degrees Fahrenheit. We don't know what this is, but we're going to go with minutes. That makes the most sense because the tea does not cool down in just seconds. Tea usually cools down in minutes. Okay, so what is decreasing? Not A, that's increasing and then decreasing. D is increasing, that's not happening. Letter F, graph F appears to be decreasing. It's at a high temperature, and then it starts to decrease over time. So time in minutes, and then this is our temperature in degrees Fahrenheit. So we're at a very high temperature, and then we start to decrease quickly and then kind of flatten out. So that's going to be for graph F. Letter E, the commuter flight. A commuter flight between two cities in Oregon takes about 40 minutes. The plane increases its altitude for the first half of the flight until it gets to 18,000 feet. And then it descends for the second half of the flight. The plane ascends and descends at a constant rate of 900 feet per minute. So, as we've been doing, we got our independent and dependent. And as we read about this, we have time in here, okay? Time is our independent. And they're talking about minutes. And then our dependent is going to be our altitude, okay? That's what the elevation is. Altitude is as the plane goes up and down. We're talking altitude, which is in feet. So what of those two remaining graphs, A and D, is increasing and then going to be decreasing? So that's what happens to a plane. You take off, you keep increasing, 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 and then depending on how long your flight is, sometimes you keep increasing, increasing. Sometimes the plane will kind of fly at a same height. All right, whoops. And then sometimes if it needs to, it might go up a little bit more. But then at some point you're going to land, and then it starts to turn down to get to the runway. So it depends on the situation. On this one, it's going to be letter A because it's increasing, it says, and then once it gets to the max height, it starts to turn down because it's a short flight. Then because you see it increases and then decreases like that, means it probably was a short flight. And then the dependent is the altitude in feet. So then process elimination says cross country here, letter F. should go with graph D. Brady runs for his high school cross-country team. His strategy for each 5-kilometer race is always to begin by increasing his speed so that by the time he reaches the first kilometer, he is running at a speed of 0.3 kilometers per minute. He maintains that speed for the next 2 kilometers. He then gradually speeds up for the remaining 2 kilometers so that when he crosses the finish line, he is running at a speed of 0.5 kilometers per minute. So what I notice again here is for the independent variable and the dependent is time, okay? Our time, not a second here, let me go back. Speed, okay. Yeah, because we don't have distance here, we got a rate. So let me go back to that actually. It's not gonna be time. I do have time in there, but I don't think the time's gonna help us. Because what we're talking about then is increasing his speed over the amount of distance. So in this problem, actually the independent variable, independent quantity, is gonna be his distance. Because depending on where he's at on that 5 kilometers, is where he's gonna either increase his speed or maintain it. So the dependent in this case is gonna be speed. That one was a little bit tricky because usually we go with time. But in this case, the time not really influencing us because we're talking about distance is influencing his speed across this race. Now his speed is in that kilometers per minute. So this is going to be your distance. So depending on where he's at in the race, this is going to be his distance. And then this is going to be his speed, which is then kilometers per minute. Okay. All right. That finishes up today.